Hello everyone. In this video we will do some examples in which you have to do some different substitutions that may not seem obvious from the beginning. So you remember that always we start with the table, then go to the simplifying the integrand first, obvious substitutions, then go to the forms, trig integral, trig substitutions, rational functions, IBP. And then when you don't see any of these working, you go back again, try again. And specifically, you try a little bit different or more clever substitutions. Okay, just risk a little bit more, and that will probably give you something good. Okay, so let's start with this one. None of the obvious substitution will work here. Well, I don't have any clue how to start with, but one thing that always I try to do, or I don't like, is that if under the square root I have bunch of things added. If it was square or quadratic under the square root, I was okay, I would do that. But this is linear. And why don't we change it to one big piece, knowing that linear substitution usually doesn't have that it's not expensive for us. I mean, we don't need to have much of things there. So I'm using substitution here, setting u to be 2x, the whole linear term under the square root. This way du is going to be 2 dx. And then you look and say, okay, so this way I have this as root u here, and this guy is half of du. That's good. How about x? Okay, in these cases, well, you can solve this for x, yes? So u minus 3 is equal to 2x, then x is going to be u minus 3 over 2. So you apply now this for x. So we'll have u minus 3 over 2 to the power 2 root u, and then half of du. And this is 1 over 8 integral of u minus 3 is u squared minus 6u plus 9 root u du. And you may say that, oh, again, back to something difficult. But remember, if you simplify, if you expand this, you will get integral of, this is u to the power 2 plus u to the power half. This will be u to the power 5 over 2 minus 6u to the power 3 over 2 plus 9u to the power half. And this is 1 over 8. Now 1 over 7 over 2 u to the power 7 over 2 minus 6 5 over 2. Remember, u to the power n, the integral is 1 over n plus 1 u to the power n plus 1. Yes, so I'm doing that, and this is 9 over 3 over 2 u to the power 3 over 2 plus c. Okay, let me get a little bit more space here. Well, then I'm done. The integration is done. I just need to simplify this, and then this is 28. What is u? U is 2x plus 3 to the power 7 over 2 minus. So I simplify that. This is 26 over 20, or 3 over 10. 2x plus 3 to the power 5 over 2 plus, this is 9 over, okay, actually, I can simplify that one as well. So this is 3 over 4, and then 2x plus 3 to the power 3 over 2, then plus c. So a little bit different nature, the substitution, and then we turn that to what we wanted to have. Okay, let's do another example. Yeah, you see, None of the things will work again. At least there's no obvious substitution. Again, I have square root of a linear term. So why don't I try to do exact same thing? Substitution. Make under the square root a solid variable. So this will be du is 2dx. And then here you see that u minus 1 over 2 is going to be x. So this way we have integral of 1 u minus 1 over 2 minus 1 root u, and this is half of du. Very nice. But even if we now multiply, expand it's not going to help me at all. So I have to come up with another idea. So let me just simplify and rewrite one piece. You will notice what I mean this time. So this 2 up there. What is done here? Okay, 2. You see, if I put these together, then okay, I have the derivative of root u here. So that is another sign for me that maybe I should do another substitution. This time I will put v, and I will put root u for that, and then dv is going to be exactly what I have up there. And from there you see that what v squared is u. So now I can change everything to v integral, transfer it to the new variable. So this will be v squared minus 3 dv. Oh, nice. Now this is something that you already know how to deal with. It's rational function. That's the first important thing. This is one of the simplest one you can do. Go to the partial fraction decomposition, or you remember that we had integral of dx x squared minus a squared d equals. So this was one of the items, new items in the table. While you can compute this yourself, definitely, but now you can use it because it's in the table. So here a is indeed root 3. Root 3 squared is 3, yes? So then I don't need to have the integral, and I'm straightforward. I will go to the 1 over 2 root 3 ln of x minus root 3 x plus root 3 plus c. Oh, okay, I made a mistake there. I need to use my own variable, which was b here. Now I will go back to u there. V is root u, so root u minus root square root of 3 square root of u plus square root of 3. And then another step for u, we plug in what? 2x plus 1. So ln of square root of 2x plus 1 minus root 3 over square root of 2x plus 1 plus root 3. And done. Yes. So if someone tells you make this one a little bit more clear, you can actually combine these two things, and from the beginning set u to be equal root of 2 square root of 2x plus 1. That way we'll go a little bit faster, but the way we discovered this was also important for us. Okay, let's do one more example here. When we were working with the square roots, substitutions, remember that if you had e to the power something, ln of something, sine of something, those some things were the candidates for the substitution, but most of the time we had the derivative of those guys right as a factor of the integrand. Here I don't have, but I don't have any other choice as well, so I will go with the substitution, setting u. Okay, I will use a little bit different substitution this time. T equals to root x, and then from there dt is equal to 1 over root 2 root x dx. Well, from here you see, okay, I don't need that part. Okay, so e to the power root x dx. But I don't have this coefficient part. Why don't I then multiply and divide and generate that part myself? So I will do 2 root x e to the power root x 1 over 2 root x dx. Okay, so this will give me 1 over, you see, this is now 2t e to the power t dt. Done. My integral is now one of the forms that we know how to handle. This is a polynomial t times e to the power t. So integration by parts will work here, setting u to be t dv to be dv e to the power t dt. Then from there we have du as just dt itself, and v is going to be e to the t. So this is 2 times uv minus integral of v du plus c. So this is 2 t et minus et, integral of et is et plus c. Well, we can simplify this a little. Oh, okay, I forgot that one there. So now I can do this. But remember that I have done a substitution. So this will be 2 root x plus 1 minus 1 e to the power root x and then plus c. Okay. So sometimes this strange kind of substitutions work. You have to spend time and see if it works or not. So you just came to mind, and then you try it and see if it works or not.